Hey, so I haven't posted in a while. Haven't been doing a tremendous amount of work, but gotten somewhere now, and I thought I'd show you where I was. As you can see, I've got a new test rig. This is using my old Creality board, which I replaced with a SKR E3 Mini. So this is one part of a triple Z axis that I'm looking to use. I've got all of the parts available for it now, but because I only have the one 3D printer, I don't want to put anything into service until I am certain that it will do the job, so at the very least, if there are problems, I can print the next thing. I appreciate that a lot of people have a second 3D printer for exactly this situation, but I'm not quite there yet. But as you can see, I could probably get to that stage relatively quickly. I've got most of the parts, but maybe that's the next project. Anyway, as I've previously said, the whole point of this is a Magnetic-Oldham coupler to disconnect the Z-axis support, which in this case is running on a linear rail, from the lead screw. Now, a lot of people are using ball screws and cheap ball screws at that at the moment. Now, I'm not. The reason behind that is relatively straightforward. Ball screws have a lot of machining to allow them to connect to standardized setups, a thrust bearing, a standard bearing, then a coupling to the stepper, and potentially another bearing support. Now, that's great for very well designed industrial applications. For 3D printers, it takes up a lot of space, and the whole point of me doing this is to try and fit what I'm doing into the frame of an Ender 5. Not an Ender 5 Plus, a straight Ender 5, and I am trying to get as close to 310 mil X and Y and as much Z as is reasonable without significant changes to the frame. I've already made two small changes to the frame, and I don't want to do any more because cost, but also confidence. The frame has been fine on my Ender 5, and when you make significant changes to the frame, any XY problems that you've got or stability problems that you've got, they're all my fault again. So that's where I'm coming from. If I had the money, I would probably build 2.4 Voron of that sort of size, but I don't have that kind of money, and a lot of what I'm doing is meant to be in a budget. As an example, the motors that I am using here are ones that I have, sorry, I say motors, the steppers that I'm using are ones that I happen to have lying around from a previous project. And as you can see, they are small. They're 22 mil high, and the holding torque is very low. If you're wondering what the hell this is, that's because the brackets here have are capable of tensioning the belt that's under here. And in the test case, I haven't fitted the M3 screws and the heat insert parts that would be needed to place those. So I've just got that jammed in there to provide tension. Again, this is just a test rig, so blah. Speaking of this is just a test rig, this is why I've got a 500 gram weight on the spur. This is one of the rear spurs, the intention being that there will be two of these mirrored of identical design, and then a very different one. Did I say rear? Sorry, these are that's the front right, front left, and a single rear spur of a different design, obviously, because it's not going at the angle here. The angles are chosen based on the bed and based on the configuration of the holes for the bed as per usual kinematic bed designs. So let's see what we can see. This is essentially just the guts of an Ender 3, Ender 5, sorry, and I've got it configured for probably more, actually double the steps that it should be so that it can move quickly. Let's move it up to what would be 150 and is probably 300 in my current setup. As you can see, it's moving quite effectively. There was a bit of a grind at the start. But other than that, it's quite nice. Now you might say, so what? Pretty much any Z-axis can do that. And I'd agree with you. One of the interesting things here is that I am binding it at the top. And this is a common mod that people in the Ender community do that is often regarded as a problem. And the reason for that is that on a classical Ender, both Ender 5 and an Ender 3, the bed itself is functionally binding the lead screw. And any lead screw should only have 2 binding points. What are normally ostensibly at the bottom and at the top, and the middle one should float. Or if you can't do that, then bind in at the bottom, essentially where the motor is. It could be at the top and the bottom, I guess. At the bed, at the motor, and then leave the other end free. The problem there, of course, is what everybody refers to as Z wobble, in the sense that the top of the lead screw on the Ender printers moves from side to side, and that translates all the way down. Now, no matter how fixed the bed is, that wobble can lead to slight juddering of the bed, which is represented in the print. So let's see what we can see here. So now we're looking straight down, and you can see the coupler, the lead screw nut. In this particular case, it's a anti-backlash nut with a spring in the middle. The hole in the center there has been cut wider. This is, again, all of my own design. Has been cut wider so that thing can be inverted from its usual configuration, which is where the connector is here, and then a spring, and then a nut. And I'll explain that in a different video perhaps, but I think that that's actually a bad idea. And the correct way for anti-backlash nuts in a gravity situation, as we have in Ender 3, Ender 5 3D printers, is the other way around, where the nut itself is pushing up, and then the anti-backlash component, it goes nut, spring, satellite nut, which is what I've got here. So let's move that up and see if you can see anything interesting going on. So I'm going to move this up to... Now, hopefully you can see, I'm going to steady the whole chassis for a moment, that there is significant degree of motion side to side on the lead screw nut. But because of the Oldham connector, Oldham coupler, there is no motion being applied. Oh, this is going to grind at the top. No, it's not. There is no motion being applied to the part that's actually coupling to the bed, which is obviously the idea of the design, as the wobble wings people, both Hevort and the various other groups that have done this before me. My design, the whole point of my design is that the rods go all the way through the coupler. Now the reason for that is to provide security and a level surface. So the point here is, Okay, is that visible? Let's move that down a little bit further. Okay, so you can see underneath here now. As you can see, these rods go all the way through and all the way through. So in the, on the top layer, sorry, knocking the stand that I've designed here. The rods go all the way through here and here on the top layer. And then on the next layer down, they go from side to side. Now the balls rest only on the rods, not on the magnets. The magnets are coupled to the rods, so the rods are the reference point, and the bearings are coupled to the rods. The idea being that in a piece that's 3D printed, if you're making, as others have done, very small rods that only occupy the space that you expect the bearings to move side to side, it's very easy to get those rods misaligned. Very easy for them to be skew, such that the bearings themselves may sit skew, they may roll skew, and their height may be different from what is intended. The idea is that with a hole going all the way through the slice, it's very, very difficult for the rods to be out by any significant measurement. That's the intention. Now I've switched from my previous 4 bearing arrangement to a 3 bearing arrangement, but I have kept the rods going all the way across an entire side, and that makes for this rather exotic middle piece with a bearing hole here, 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 and here, where the 3-point from the top meets the 3-point from the bottom at a different alignment. So this is what allows the 2 3-point sets to couple to each other. Hopefully this will work quite nicely. I've already had a couple of problems and had to reprint. One of the problems was the interface between these 2 middle slices. I've created a rig to a jig to cut these more accurately. As you can see, these are stuck out. These binding pieces at the bottom and at the top, I made them in Fusion 360 to essentially align with this, but potentially be able to be pushed out to tension if necessary. This can be pushed out to tension if necessary, and these to align. But I think this needs to be pushed back ever so slightly so that there's slew in both directions, because at the moment bottomed out is the correct position, which means that if there is any play that needs to be adjusted, there needs to be the option of play in this direction as well as this direction. The magnetic coupling force on this, with the 2 rods and the large slice magnet in the middle, seems to be, from what I can tell, enough. The bed itself has a lovely space in its circuitry to put the heating bed, to put a middle screw hole that it doesn't currently have. So once I have reprinted these, tested it out, I'll do the whole lot in ASA, and then we're looking to print again. The most interesting point is that without some degree of weight, although the bed that I'm looking at will provide that weight, this won't bind effectively. Let's demonstrate that. Yeah, you see that? That's not good at all. And that's just the twisting force being greater than the magnetic force, as expected. But the second you put any kind of weight on there, like for example the bed itself, you have no problems. So there we go. Hopefully that will soon make its way onto my printer.